Alright, today we're going to learn about how to find the distance between points on a coordinate plane. Now, when you're finding the distance, always remember to think Pythagorean theorem. And this is used to find the distance for right triangles. Again, the Pythagorean theorem is a squared plus b squared equals c squared. Remember that c is always the longest side, which is called the hypotenuse, and it's across from the right angle. Alright, so again, when you're thinking distance, just think Pythagorean theorem, which is used to find the distances of right triangles. Alright. Now, the actual way to find the distance between 2 points, there is a distance formula, which is, again, it's basically the same thing as the Pythagorean theorem, it's just using different letters. So when you're finding the distance between 2 points, we're looking for that diagonal, the diagonal connector of the two. Well, we can't really read that from a graph, so the way you find it is by doing the rise and the run. Alright, and this is just the change in y and the change in x. Change in y is just y2 minus y1, change in x is x2 minus x1. It's kind of like slope. Alright, so the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. But realize that, again, it's just the square root of the run squared plus the rise squared. So it's just the Pythagorean theorem, where your run and your rise are the legs of a triangle. So here in this particular problem, we're finding the distance between 2 points. The first thing you should always do is sketch the points. So go ahead and plot the points on a plane. Now, your sketch doesn't have to be perfect, but one thing I always recommend do is label the letter and the numbers, the coordinate. Okay. When you're looking for the distances, it's very helpful to actually have the coordinate numbers listed. Alright, so that's what we're looking for, the distance right there. Now, in order to find the distance, again, you want to draw a right triangle. Alright, so we're going to want to calculate the rise and the run. So in this case, the run left to right and the rise is up and down. So if we're going from a -2 to a +5, that's a total of 7 spots. In your head, go from -2 to 0 is 2, from 0 to 5 is 7. You do the same thing vertically from +4 to -4, that's a total of 8 spots. All right. So once you know, again, the 8 is your rise and the 7 is your run, now those are the legs of your right triangle. So you label one of them A and the other one B. We're finding C, which is our distance, the diagonal. So you plug in 8 and 7, so you do 8 squared is 64, 7 squared is 49, and when you add those up, you'll get 105. So you get 105 equals C squared, so you do the opposite of square, which is square root. So your final answer is the square root of 105. And you should be able to know that's a little bit more than 10, because the square root of 100 is 10, so it would be like 10.3 or so. So now I'm going to show you how to do this again using the distance formula. Again, I personally will always just do right triangles, but you should know how the distance formula works. So we're going to label our points x1, y1, x2, y2, and now you just plug in the numbers. So you do x2, or in this case I did y2 minus y1 first. So -4 minus 4 squared plus 5 minus -2 squared. Again, you get -8 squared and +7 squared, which again, this looks very similar to what we had before. 8 times 8 is 64. 7 times 7 is... No, it's actually 49. I'm sorry. Put the wrong number there. So you do 64... Yeah, see, I did a mess up there. It shouldn't be 56. It should be 49. I did 7 times 8 accidentally. So it's going to be 64 plus 49, which is 105. And you do the square root of it, so you get the same answer as we did before.